Hi, this is Belo. For this video, I'll be discussing surface sketching. So for the 3D surfaces, they include the planes, cylinders, spheres, and the quadratic surfaces. These are some examples of the three-dimensional figures that we'll be using most likely. And by the way, thanks to Krista King Maths YouTube for this slide. So this one will be the y-axis, this is the z-axis, and this is of course the x-axis. So that means going to the right, to this side, that's the positive y direction. Going upwards is the positive z direction. And going outside towards you is the positive x direction. So this one here, wherein all three axes intersect, is called the origin. Of course, that's 0, 0, 0 for all x, y, and z. So here, where both x and y axis are present, this is what you call the xy plane. This is when z is equal to 0. And the yz plane is the wall. This is happening when x is 0. And lastly, this is what you call the xz plane. This is when y is equal to 0. And the figure formed in this space is called the figure in the first octant. Alright? Some of the guidelines I use in drawing are, number 1 is symmetry. So what I do is I check for symmetry along the x-axis. So this one, what we do is you change y to negative y and z to negative z, and then check for symmetry. If it's about the y-axis or along the y-axis, what you do is change x to negative x and z to negative z. And lastly, for z-axis, what we do is we change x to negative x and then y to negative y. And symmetry along the xy plane, what we do is the letter that's not present here, you change z to negative z and check if there's symmetry there. The xz plane, you change y to negative y, and then the yz plane, you change x to negative x. And then if the functions go back to being the same, that means it's symmetric about those axes or those planes. Next are the intercepts. So for x-intercept, what we do is solve for the value of x, whatever that is, when you set y and z to 0. For the y-intercept, set x and z to 0, and then whatever you get for y, that's the y-intercept. Whereas for the z-intercept, set x and y to 0, and then solve for z, that will be your z-intercept. Next are what you call the traces. So if I say traces, they are traces on the different planes that I mentioned earlier. So the xy trace is basically present on the xy plane. So if this is x, this is y, this is z, the xy trace will be present on this plane. And then the xz trace, so if this is the x, this is the y, this is the z, the xz trace should be present on the xz plane. Whereas the yz trace, this is x, this is y, this is z, it should be present on the yz plane. Sections. Sections basically parallel to the xy plane, parallel to the xz plane, and lastly, parallel to the yz plane. I'll explain the sections later on. So these are basically the four. Again, let's go back. Symmetry, intercepts, traces, and sections. So let's try. Say you have x squared plus y squared plus z equals, say, 4. First is symmetry. Let's go to symmetry about the x-axis, y, z, and sometimes we test also for the origin. And then if it's for the origin, we basically change all of the variables. So let's check this first. If it's with the x-axis, we change y and z, and apparently it will not be the same. So this one does not have symmetry about the x. How about the y-axis? We change x and z, so it will not change because z here will be negative if it's changed to negative. Whereas if it's the z-axis, when you change x and y and make them negative, they will still be the same because both terms are squared. So that means it's symmetric with the z-axis. Alright, let's try intercepts. For the intercepts, you'll have basically 3x intercept, y, and the z-intercept. So for the x-intercept, when you set the y and z to 0, the x is basically plus and minus square root of 4 or plus and minus 2. Whereas for the y-intercept, if you set x and z to 0, the y is plus and minus 2. And lastly, for the z-intercept, when you set x and y to 0, z is 4. So you have those intercepts already. Next are the traces. So for the traces, you have 3 planes. So let's have the xy trace, the yz trace, and the xz trace. Alright. So for the xy trace, let's look back at the given function. Remove the z there. Because on the xy plane, z is equal to 0. So we'll have the function x squared plus y squared is equal to 4. Basically, it is a circle of radius 2. Okay. For the yz trace, so this happens when x is 0. So that's y squared plus z equals 4. This is a parabola. One is squared, the other one's not squared. And then xz trace, similar to the one above, that's a parabola. So if, for example, let's just say, if we draw that in 2 dimensions, let's just say this is your x and this is y. So 1, 2, 1, 2, 1, 2, and 1, 2. That forms a circle. Sorry, my circle's not that good. For the parabola, but then this one involves the y and z axis. So let's just say the y axis is the horizontal and then z is the vertical axis. So when y is 0, z is 4. Whereas if z is 0, y is plus and minus 2. So let's just say this is 4. So it's a downward parabola. Now, this one, let's just say this is x, this is z. If z is 0, x is plus and minus 2. And then if x is 0, z is 4. So roughly similar to the one we have there. It's a downwards parabola. But then it says there, traces on the xy plane, yz plane, and xz plane. So let's draw them on their corresponding planes. So I'll draw one of each. So here, On xy, it is a circle. So since this, the x and y plane, I'll just draw on the first octant. And then yz, so again, this is x, this is y, this is z, x, y, and z. So since I'm dealing with the yz, this is 1, 2, 3, and 4, 1 and 2. So it's a parabola opening down. And then for x, it's 2. For z, again, it's 4. So z, y, and x, it's a parabola. Okay? Now, let's try drawing the figure all together. So, 2, 1, and 2. So 1, 2, 3, and 4. So again, better. That's a circle and then a parabola and a parabola. So basically, this is the three-dimensional figure that we'll be forming. But then, one of the last sections that I mentioned earlier is the sections parallel to the xy, parallel to the xz, and the yz. So if, for example, I ask you, draw sections parallel to, let's just say, the xy plane. So what I do is this. I draw the three-dimensional figure. And then since it's parallel to the xy plane, I can move along the z direction. So this is the y. This is the x. So if I move along the z direction, let's just say I move 1 unit for z. This is 1 unit. 2 units for z. That's the second unit. 3 units. And this is the fourth. Okay. If it's 1 unit for z, look at this. That crosses that point and this point. However, since I would want to draw traces or sections parallel to the xy plane, let's look at the xy trace. The xy trace is a circle. So that means it should form a circle as well. Here it touches the point there, and here I should draw a circle. Here, because those are basically circles, and then they're becoming smaller and smaller until they meet at one point. So this is basically the same shape, but then I have drawn sections here parallel to the xy plane. What about if you were asked to draw parallel to yz plane? Okay, what we do is, let's redraw that. But then I said yz plane. So you move along the x. If I move along the x here, I touch the original graph here and there. But then look, parallel to the yz plane, the y and z plane, the trace there is a parabola facing downward. So this one should also be a parabola. And then when you move, it's also another parabola until you meet at one point. And lastly, what about if I ask you to draw parallel to the xz plane? Drawing that, again, parabola, parabola, and circle, parallel to the xz plane, so I can move along the y. So if I move along the y, let's say y is there and there, I will basically just copy the trace of the one on the xz plane. So that's a parabola facing down, and so on. So those are the sections drawn. But then the three-dimensional figure is, of course, the one here in yellow. Next, What about if I ask you to draw, say, x squared plus z squared is equal to 1? So if I skip the symmetry and then let's just draw the intercepts. So if I have the x, y, and z axis, this is the x, this is the y, that is the z, you'll notice that there is no y in here. And just like the sheet I showed earlier, this is actually a cylinder. So let's go to the intercepts. If x is 0, z is plus and minus 1. So z is plus 1 and minus 1. But then as I said, we won't be showing the other octants. I'll be focusing more on the first octant. So I'll just make this a bit bigger. Let's just say that's 0.5. So let's just say this is 1. And then if z is 0, x is positive 1. So it's this one. And you notice that this is an equation of a circle on the xz plane. Okay. Now, the thing is, you'll notice that it does not intersect y at all because y is not contained in the equation. So this is not a quadratic surfaces. This is simply a cylinder. So if, for example, if I extend this one, what I would do is I draw the same figure parallel to the yz plane, xz plane, and then the figure formed is still quarter of a circle like that. And then let's just extend that here. So in the first octant, this is what's shown, but then actually it's a cylinder like that, like that. But then you won't be showing all of it, only the one in the first octant. And then I could draw rulings that's parallel to the axis, which is the y-axis. So this one. So this is the shape. It's actually a cylinder. Now, what about if I draw there, if I say 1 minus y squared? Okay. If z is 0, y is plus and minus 1. So, plus and minus 1, I won't draw the negative side. So this is y, this is x, this is z. You'll notice that it does not intersect x at all because it's not contained in the equation. So if y is 0, z is positive 1. Okay. However, what you'll notice there is that, again, this is 1, this is 1. What you'll notice there that this one is actually an equation of a parabola. It's actually a parabola facing down. However, we won't draw everything since it's the first octant. And as I said, since it does not contain the x, we can draw our rulings parallel to the x-axis. And then our shape is actually like this. So when we draw the rulings, it's like that. So it's actually a cylinder. I'll just make this yellow so it's more prominent. So that one, it's parabola. So it's still a cylinder. What's the shape? It's like this. It's like that. But then it extends, of course. Next, for example, we have z equals x squared plus y squared. Now that all the letters are there, let's have that. If x and y are 0, the z is 0. So that means the origin is the intercept of everything. Now, it's a bit tricky because we're starting with a point. Maybe what we can do is, let's try doing the traces. So the xy trace is what? It has to be only x and y. So x squared plus y squared is 0. So it's a point. However, you'll notice that if I move above, let's just say if z was 1, it forms a circle. If z was 4, oh, it still forms a circle. Okay, what about the yz trace? The yz trace is z is equal to y squared, so x should not be present. It's a parabola opening up. So this is the y, this is the z, this is the x. So it's actually a parabola opening up. And then if I have the xz trace, it should only be the x and the z that's left. So you'll notice that this is an equation of the parabola on the x and z plane. So it's like this. Okay. So earlier I said the xy trace is simply 0. But then what if we move higher? When I say we move higher, we start with 0 is equal to x squared plus y squared. What if z was equal to 1? Isn't it an equation of a circle? So if z was equal to 1, that's a circle with a radius of 1. If z was equal to 4, so that's 2, 3, and 4, that's actually a circle with a radius of 2. So it's this one. It forms a paraboloid. So our shape is actually sort of like this. However, we're only showing the first octant figure. So if you would want to draw the section spiral, so it would form something like this. So this is part 1 of the video. For the second part of the video, I'll be drawing more surfaces and then solving the volumes of those surfaces using multiple integrals. Thank you very much for watching.